Welcome, everyone, to this month's second Tuesday session called Why Delta E Doesn't Always Work. Now, it's going to sound like I'm bad-mouthing Delta E, and I'm really not trying to. Delta E is a phenomenal equation. The version 2000 is the best we've had that I've seen, but it's got problems. And that's what we're going to talk about today. So as always, please follow us on LinkedIn, and please ask any questions that you have through the chat window in Zoom. Beth will be moderating that chat window, and she'll try to stop me as I'm in the presentation so we can answer the questions as they come in. So my name is David Hunter, and we'll get started. So per our color conference, people were asking for us to have a better way to explain what we've done, which is new in ChromaChecker for our users. And I'll tell you, our engineers work so quickly, it's hard just to document everything that they improve every month. But we're gonna start out with the beginning of our second Tuesdays of some recent ChromaChecker improvements, and these are just from the last 2 weeks from our color conference. And for all those that attended the conference, it was great seeing you. We got great feedback. We got feedback of the sort that other color conferences, everyone's more snooty and they're very protective of their information, and it's all this keep secret. Our color conference was very much, hey, you know, I'm here to help. Everyone's here to help. Everyone was sharing information. It's always been this way, and I think that's something that sets our conference apart. So first off, snowflake improvements. The snowflake control strip is now in the same color space as the snowflake. So if you tell the snowflake to be in a CMYK color space for your Epson, the color bar will be in a CMYK color space as well. And the snowflake tolerance location where you put your +L+A, which I'm going to cover later in the presentation, now mirrors what it looks like in the software interface on the cloud when you set the tolerances. So it becomes much clearer. And the control strip can now be added within the capture software. Just a couple weeks ago, you could only print the snowflake with a control strip from the cloud. Now you can do it from within our client capture software. And we'll actually do some measurements of a snowflake a little bit later. A second big improvement we've made is, I guess we didn't realize how many people were using our custom control strips, which have spot color placeholders. The purpose here is that you can have a control strip that might be, let's say, a G7 compliance control strip with all the necessary G7 patches and the solids and the overprints. But sometimes you're running a rich job, which requires rich colors, and next time you're doing a Barilla job that requires Barilla colors, and next time you're doing a Pepsi job that requires Pepsi colors. You don't want to have to necessarily build umpteen different control strips. You can build a control strip with up to 12 different variable placeholders that can be substituted at the operator level. So you only need one control strip for any combination of process plus up to 12 spot colors. So that's a big improvement in terms of number of colors that you can substitute, and therefore limit the number of control strips you need to manage. Next is the universal data set. I've had a number of you email me going, hey, what's been up with the universal data set? And I got up at 3 in the morning this morning to listen to the FOGRA color call. And Andy, the head of FOGRA, essentially said, or the way I interpreted his discussion in today's call was that the universal data set status has been delayed. If you came to the conference during our industry update, we shared with you that it was a very dynamic situation right now. Never should have been dynamic, but the fact that one of the beta sets had the G7 plus math put into it really threw Europe and It threw them for a loop. And today in the call, I heard Andy kind of blame the delay on the fact that the G7 Plus data set screwed things up. So that never should have happened, but it happened, and we have to live with it. So now we're looking at probably the next, I think, ISO meeting is in November. They're going to be talking about it in a work group in May, but we're not going to have a universal data set as soon as we were hoping we were going to have it. We're going to have to wait a little bit more. So those of you who were at the conference were able to see the visual images of what the universal data set looks like. The concept is that instead of having a Foger data set and a Grackle data set, we have one universal data set. It's probably going to, we'll probably call it, and this is all unofficial, of course, but something like maybe Grackle 2026. And the E factor difference from Grackle 2013 is 2. So it's not a big deal. It's and this isn't approved yet, so these numbers are all still up for discussion. But the concept is unifying one data set for printing on coated paper worldwide. And unfortunately, that's been delayed. Another new improvement for all you Print Factory users out there is we now support the a LUT for the Print Factory. So using any of our tools that build spot color lookup tables, you can save it as a .color map file, import it into your Print Factory, and now you've got a LUT for that. If you have other RIPs that have custom LUTs that you want us to support, please do this. Make a LUT from your RIP software, export it, or give us a file that you can import into the RIP so we see the format of it. Get it to us, Pierre@ChromaChecker.com or support@ChromaChecker.com, and we can start writing the interface for it so that more people can take advantage of LUTs. In addition, we've added support within our instrument inspector tool, which tracks an instrument's performance over time and adheres to ISO 23031 2020 for how to track a color measurement spectrophotometer. We now have the ability to support spherical instruments. So before it was M0, M1, M2, M3. Now it's spec in, spec out, with and without UV. So we've added capabilities along those lines. And then we've also added within the accountability inspector the ability to customize how long it takes a notice to be sent to either the operator or the manager if no data from a printing device has not been received by the ChromaChecker cloud. It used to be limited to a couple choices. I think the shortest choice was like 72 hours, which is like 3 days. Now you can make it much faster. So with that, let's get on to our topic for the day. And the topic for the day is, why doesn't Delta E always work? So the agenda, we're going to talk about how to quantify color differences, what is Delta E, a little bit of the history of Delta E, cover some terms and definitions along the way. Then I'll give you some exercises, websites that you'll be able to go to experience different Delta E formulas and different Delta E numbers, so you can see what a 5 Delta E in LAB looks like versus a 5 Delta E in Delta E 2000. And through these exercises, you should be able to learn how to visualize your Delta E's for important colors. And if you are not a ChromaChecker user, you can get a trial of ChromaChecker, and you'll be able to take your specific color, like a Ritz red, and visualize all 42 Delta E's for that given Ritz red in every dimension. So hue, saturation, lightness, 42 different Delta E's at, let's say, a Delta E 2 or 3 or 6, whatever you want. So you can visually see it for the first time, which is really interesting. I've never seen anything like it. And for quantifying your color expectations, you've got to be able to see what the color differences are. And that's the whole purpose of a tolerance, is to be able to quantify a sellable color match. So a customer can say, you need to make Ritz red within 3. And everyone knows what a 3 is. And as long as you manufacture within a 3, it's good. If you don't manufacture within a 3, it's bad. And that's the hope of what Delta E provides. But as you'll see, Delta E often fails on this process. But we have a new way that fixes that and addresses that. And we'll talk about how to set the tolerance that actually represents color match expectations. So with that, how do we quantify color differences? Well, when we're quantifying color differences for, let's say, how close is my cyan on my printer to matching grackle, or how close is my rich red to what Rich says rich red should look like, that's one type of color match. You're comparing one color to another color. Then you have a second type of color match where we're comparing one page to another page or one image to another image. And so in both cases, it's super helpful to be able to quantify the color match. And for quantifying the color difference numerically, we typically have used delta E through the years to quantify the difference between one color and a second color. And then for defining the match via a numeric difference between pages, like how close is my proofer to grackle? I asked G7 experts, how close is your proofer matching grackle? I had G7 experts looking at me like I'm asking a stupid question. It's a really simple question. How close is your printer printing to grackle? Perfect would be 0, which you're never going to get, but we can all hope we're going to get a 0. But I mean, everyone's always experienced multiple G7 compliant prints that are different from one another. And I've always asked myself, which one's most right? And by using E factor to quantify how close the print is to grackle, the one with the lowest E factor is the one that's most accurate. So this becomes very helpful. And it's also very helpful because it allows us to, for the first time, compare the difference between two prints to one another. So not only do I know how close the print is to grackle, but I know how close my proofer is to my press, or my proofer is to my indigo. And all E factor is the 95th percentile of delta E. So it takes all the delta E's between the print and the proof, and it takes 95% of them, so throws out the 5% worse, and whatever the 95th percentile is in delta E, that's the E factor. So it's saying 95% of the colors are within that delta E of the other printer. So think of E factor as a type of delta E, which is also affected by how the delta E equation is built. So that's how we quantify color. Yeah, there's a question?
Yes, there's a question. Can we calculate metamerism with delta E?
So we calculate something called a metamerism index, which is it's like a delta E, which tells us how volatile certain colors are to one another. So it's not necessarily a straight delta E, but it's a form of it. So great question. And then in this sample, I'm showing delta E differences between the red on the top and the red on the bottom, and the E factor differences between the three images down below. So it becomes a very easy way to quantify difference. So we know, is the print sellable? Is the spot color sellable, or is it not? So when we're talking about color standards, and we're talking about like the Ritz red, think of the gold color being the bullseye, and then each ring around the bullseye being a delta E. 1 is the smallest point at which the eye can typically perceive, and different people perceive different types of delta E's, as you'll see. And then it goes up from there. A 3 is bigger than a 1, and a 9 is bigger than a 3. And in this way, if I come back to this graphic, I can quantify how well printer 1 is reproducing, let's say, Ritz red at 3.4. Printer 2 is reproducing it at 2 delta E. Printer 3 at 2.9, and so forth. So we can set a delta E tolerance. And we want this number to mean that it meets expectations. Where the problem comes is if I ask for, let's say, a 2, and during print production we measure it, it's a 2, and then we give it to the customer, and the customer says, that's not acceptable. To my eye, that's too far off. And you can say all day long that it's a 2 when you said a 2. The customer's always right. And if they don't like it, they don't like it. And that's one of the things you'll see with delta E is that a 2 isn't always a 2. A 3 isn't always a 3, depending upon where the color is off in the spectrum. So when we talk about developing delta E equations, let me back up here. The whole purpose is to be able to quantify color difference. So we need a color space to start. And for the past 100+ years, work has been done by the CIE, International Commission of Illumination, to figure out how the human eye works. And this independent nonprofit organization focuses on light, color, and vision. And they've defined the gamut of the human eye in a color space called CLAB. I'm sure many of you have heard of CLAB before, and it's meant to represent the gamut of the human eye. And it has the 3 attributes that we know as humans define color. So if you think of a globe, the North Pole is pure white, South Pole is black. The gray wedges step through the core of this model. If we go around the circumference or the equator, if you think of the Earth, we've got our hue angles, our red, orange, yellow, green, blue, indigo, violet. So Roy G. Biv. And then as we move from the inside out, we increase the saturation. And when we're talking about the LAB model, you just think of apples and you think of fruit. So L is lightness, light to dark. The A-axis is green apples on the left, red apples on the right. And then the B-axis is yellow bananas on the positive and blueberries on the negative. So in this way, you can, if I give you a LAB value, you could plot it in this color space, which represents the gamut of the eye. And I have a illuminant dependent color, meaning if I change the lighting for this color space, the color can change. So that's why I put D50 for print, because that's what we in the print industry typically use. But as a brand, you ideally shouldn't be defining your color in a LAB color space. Ideally, you should be defining it in a spectral space, which is illuminant independent. But that's a topic for another day. In this conversation, we're talking about the limitation of lab, and it is illuminant dependent. Now, to show you an example, yes, question.
Yes, question is, the red-green axis aren't in real a magenta-green axis in lab space, LAB space?
So yeah, the A-axis represents really from the red to the green. So if you look on the right, the positive A is red, the negative A is green. And then the same with the B-axis. And if, again, we look top down, we've got our Roy G. Biv. So as you go counterclockwise around what you see on the screen here, we go red, orange, yellow, green, blue, indigo, violet. And it just so happens the A and the B axis kind of line up on red and green on the A and yellow and blue on the B. Did that answer the question?
I don't know, the difference of the question was red, green axis, magenta, green axis. There was, that looked like a differentiator. But red and magenta basically the
red
same,
and magenta are next to each other. So yeah. So this is a graphic mapping all the Pantone colors into the CLAB color space, because every color that we can see can be mapped into the CLAB color space, along with the Grackle 2013 gamut for coated paper. And you can see that 55% of the Pantone colors are out of gamut, meaning they can't be reproduced within 1 delta E of the original color. So 55% of the colors are within gamut, 45% of the colors are outside of gamut. And if I use our ChromaChecker's virtual spot tool over on the right, you can see which colors are in the most out of gamut. And you'll see reflex blue is one of the big offenders. Reflex blue is going to be one of those colors down to the left at 10 delta E out of gamut. Pantone violet is 12 delta E out of the gamut for Grackle. And, you know, Pantone does this on purpose because they want you to buy Pantone inks. They don't want these colors to easily be reproduced using CMYK. So they create very vivid colors so that you can't make them in many cases with CMYK, hence the 45% value. But delta E makes this all possible. It allows us to quantify colors that make color communication and setting expectations very useful. So when we look at another contribution that CIE has provided the industry is they introduced CLAB in 1976, along with the first delta E equation, often known as either LAB or 76. This first delta E equation treated the three aspects of color in the same way. So it treated lightness the same as hue, same as saturation. And it was literally a sphere for each color. And we've learned that our eyes are very sensitive to a hue change and not so sensitive to a saturation change. So through the years, we've improved the delta E 76 equation, and the industry has come up with the CMC equation, a 94 equation, and now the 2000 equation with multiple derivatives in between. We've got 17 plus delta E equations that have been developed since 76. The standard is settled on delta E 2000. And there hasn't been a new standard in 25 years. If you think about that, people, that's pretty amazing. That would make you think that delta E 2000 is awesome, right? No, it's not. And speaking from personal experience, I can tell you that it's not. And one of the reasons why it's not is that the CIA color space is not linear, because our eyes aren't linear. We see more shades of green than we do shades of red. And McAdams came up with the concept of these ellipsoids, which think of them as footballs that are stretched in the saturation aspect because our eye is lenient in saturation, but skinny in the hue aspect. So it becomes more, shall we say, refined as the hue changes. And this has improved our delta E formulas, but it's not great. And there's been talks, boy, Ed Granger's been talking about switching out the LAB color space for 20 years. But so much of our industry is based on CLAB, such as all of our ICC profiles, all of Photoshop color conversions, a lot of what we do with the lighting. CLAB is just so intertwined in so much of our industry. Trying to take that out and put another color engine in is kind of mind-boggling. But there are attempts to have this happen in the industry to address some of the limitations that CLAB has. And why delta E doesn't always work, this is a great little exercise called our spot color tool that you can get to off of the ChromaChecker homepage. So I'm just going to do that right now. I'm going to go into the spot color exercise and show you, instead of talking about it, I'm going to show you how fantastic it is if you're learning about delta E in colors. So here I've got pastel colors, gray background, delta E 2000 at 5 delta E. So each of these slices that you see around the circle is 5 delta E different from the center. And if you don't want the line there, I can turn that off and say show, and now that line is disappeared. And I can go ahead and change this to a 2 and say show, and now each of these differences is a 2. And if I change it to vivid color, now you can start seeing, in some cases, a 2 more than others. So like 2 on the blue, I hardly see at all. The 2 on the magenta here, I see it all over the place. And I can change the formula now to 76 and say show. And now at 2 at 76, I almost don't see any difference between any of them. And if I change it up to, let's say, a 5 and say show, you start seeing some differences. And I can put the isolation lines back in there. So just a super tool to go in and play with some of the different formulas and see what the different levels of delta E look like in these formulas. And like I said, that's a really nice little tool to educate people on what delta E is. Now, from personal experience, back in 98, I pioneered this tool called a pilot color tolerance exercise. And the concept was to quantify what a person's expectations were for a color match. Because I'd go into a site and their expectations would be a 2, but their equipment was a 6. And I'd tell them right off the bat, well, after I did this exercise, I could tell them right off the bat that you can't be a 2. Your equipment is horrible. Your equipment is a 6. The best you can be is a 6. You better ante up money for your equipment to be able to be a 2. And I go into a customer and I work with them to get the color as good as it could be. And then at the end, they'd say, oh, that's not good enough for me. And I'd be like, what do you mean it's not? It's as good as you get. Well, we were expecting something better. It's like, okay, so this became my cover my butt tool. I'd go in and before I'd start working with them or before I'd even quote them, I'd see what their expectations were to see if they were realistic and if their equipment could handle it. And I never lost a job after that because everything was quantified. Now, GATF and PIA sold it for years. And I developed it initially on the 94 equation, the delta E 94. Then delta E 2000 came out and GATF, the Graphic Arts Technical Foundation, was like, hey, Dave, you should redo this for delta E 2000. So I did. And 3 out of the 8 colors rendered better in 94. And it's like, well, geez, should I use 94 on 3 of them and delta E 2000 on the rest? It's like, no, you shouldn't mix tolerances like that. But I knew back in 99, 2000 wasn't the cat's meow. It wasn't the best thing since sliced bread. So, and we'll again prove that as we go through here. Now, one thing people would always ask about the pilot exercise was they'd say, hey, it's spot colors. Let me see process colors. So that's why our ChromaChecker E-factor exercise does the same thing for process colors. It lets us quantify what a person's expectations are to have one page match another page in a numeric number called an E-factor. So we know what the expectations are for the person and we know what the expectations are for the print process. So when we're defining a tolerance, it's all about meeting the customer's expectations. And what's required is whatever metric you use to quantify the color difference, the customer will accept. And that metric has to quantify the color difference uniformly, meaning a 2 delta E has to appear the same no matter where the color difference is in the spectrum. And the 2 delta E has to appear the same no matter what the color is. And let's just jump here and show you this tool called our variator. Introducing ChromaChecker's Variator PDF. This allows you to take any color from any library or a color that you measure and create all 42 delta E's for that color. So what you're seeing here in this gold is 42 variations of a 2 delta E. And as you look across these 42 variations, I'm sure you'll agree with me that the center circles, the difference doesn't look very large, but the top and bottom circles, the difference looks very large. And that reference on the right tells you which colors are the reference. So just to flip out of slideshow mode, this is the reference color that you compare it to. Look how different the light a 2 delta E is from the reference color. This is the reference color, this whole center circle, this whole center circle, this whole center circle, and then this donut down below. And that's the 2 delta E on the dark side. And that's why many of these delta E equations have attempted to scale L at a different factor through the years, because typically L, we see a difference in L bigger than we see a difference in A and B. So I hope you would all agree with me that these are not all the same visual difference, which means delta E fails in terms of a metric that appears the same no matter where the color difference is. And if we jump ahead to Bill Meyer, a color expert, he wrote this back in the 70s, which was just way ahead of his time. He said, when choosing the right color tolerance, select a single method of calculation. So whether it be delta E 2000 or what have you, choose one method of calculation. Always specify exactly how the calculations are made. Never attempt to convert between color differences calculated by different equations, so don't mix and match. Use calculated color difference only as the first approximation in setting the tolerance until they can be confirmed by visual judgments. In other words, verify all calculations visually. In other words, make a variator. Now, until we introduced our spot color exercise and our variator, I've never seen any other vendor give you all 42 delta E variations for any color. This is really interesting work for the industry. It's so helpful. And you can imagine without this variator, you couldn't verify all calculations visually. It wasn't possible. So customers, how many times do customers choose, oh, I want to be a 2 delta E because that's what they've heard in the industry. I'm going to be a 2. And it's like, you might, 2 is really hard. A lot of things have to line up in order to get a 2. And it makes it really hard for a printer to make money if you're trying to manufacture color at a 2. So the more we can educate a customer and back them off of a 2 tolerance to maybe a 3, a 3.5 tolerance, the more money us as printers are going to make. And then lastly, number 5, which I'm going to refer to multiple times for the rest of the presentation. Always remember that nobody accepts or rejects color based on numbers. It's the way it looks that counts. And that's, again, where variator really comes in, showing you the way it looks. And so here I pulled a 3 delta E variator across a number of different colors. And again, you'll see these are random colors I came up with. I didn't hand pick colors that make delta E look bad. Frankly, they all kind of look delta E look bad when you look at it at this degree of interpretation. And when we're trying to make money reproducing colors to our customers' expectations, this all counts. This all plays into making that customer happy and accepting the color. So if the tolerance is all about expectations, well, then we could set a tolerance, let's say a 3, and show the customer a printed variator of Ritz Red at a 3 and cross our fingers that they're going to accept it. But when you see this for a 3, they're going to say, yeah, you know, maybe I could live with the 3 in the middle 3 circles, but no way could I do it on the top and bottom. So drop the tolerance down to a 2.5 or down to a 2. And you don't want to do that as a printer. You don't want to give up any more tolerance than you have to. So if we could compromise with the customer and say, hey, you know what, let's keep it a 3, but let's just lop off the L star for high and low, and we'll have what we're calling a snowflake tolerance. So it's still a delta E, but we're eliminating the light delta E's and the dark delta E's that you find offensive. Would you live with that? And in most cases, they're going to say yes, just so it delivers to what my eyes' expectations are, I can live with that. And so, boom, you've just bought yourself a whole delta E of tolerance in manufacturing their brand on your production lines. That is invaluable from a profitability standpoint. So we're going to show you how you get there. So again, we talk about verifying all calculations visually. This helps us figure out where we need to adapt our color space to accommodate where delta E doesn't always work. And in the scenario I just shared with you, you want to make allowances for a few colors. And so variator proves delta E has problems that cost time and money, negative profit, and it manifests itself in 2 ways. What are called false fails and false passes. I showed this at a trade show recently, and this brand company said to me, oh my goodness, this is the holy grail. You just, if you can deliver what you're promising here, you've just solved all my problems from a quality perspective. Because so many times the printer might get a false fail on the print, which means the visual difference is acceptable, but the delta E failed. So the printer now has to edit, chase color when it's not even warranted, but because the number doesn't line up with the tolerance, you're chasing your tail. And then the other aspect is true as well, where it's a false pass, where it says, oh yeah, it is a 2, but maybe it's in the L star area where, yeah, technically it is a 2 delta E, but visually it looks like a 3 or 4. And so when the customer gets it, they're like, this is not acceptable. And remember that fifth rule was it's the way it looks that counts. It's not the number. So how do we fix this? We fix this with this introduction to the ChromaChecker snowflake. The ChromaChecker snowflake allows you to set your target color as the center of the snowflake, and then see the difference of the color in the 3 planes of delta E. Delta E is in one equation doing the delta L, delta A, delta B all at once. And I can tell you, based on my working with delta E 2000, when the equation first became available for comment back in '99, it was like, I don't know how we're going to improve this. It's broken, but I kind of am a math geek in a way, and I was like, I have no idea how to fix this. And guess what? No one really else has in 25 years. Hence, we haven't seen an attempt at a new delta E equation. So now what we're doing here is we're saying, okay, delta E, trying to do one number for all of it might be too much to chew. Let's break it up into the really 6 planes: plus L, plus A, minus A, and B. And there we have 6 planes. And now we're seeing as the color goes off, and remember the green apples, and so the blue on the left, yellow on the right, green on the left, red on the right, lightness on the top, darkness on the bottom. And we're putting a reference patch next to each of the variations so you can see how that color is moving. And we can weight this snowflake, so we can change the weighting of it. But this allows a customer to take their Ritz red color and then draw. If you guys came to the conference, you did this as an exercise. You drew a shape around the colors that were acceptable to you, leaving out the colors that were not acceptable to you. So in this way, we have a non-contiguous delta E, hence a snowflake tolerance, that you can customize, that represents your eye's expectations. And this is one of the new things we added, was on the delta E print, you've got the spot color tolerance in the same layout as the snowflake. So plus A, minus A, etc. That you then take the number, that's in the patch and you apply it to the spot color tolerance, which you will then import or transcribe into the ChromaChecker software to set what your tolerances are. And these tolerances can be downloaded into your exact. Now, the exact has one limitation, in that the exact, all the numbers for each axis, so the L, A, and B, have to be the same. So in this scenario where I have a minus A at 3 and a plus A at 4, the exact couldn't handle that because it's expecting the same number for plus A and minus A. But other than that, the exact can use the snowflake tolerancing, and we can save the tolerance into a set that can be checked with the exact. So now we have an actual metric that gives you pass-fail based on visual expectations. No more false fails, no more false passes. And remember, nobody accepts or rejects color because of their numbers. It's the way it looks, and Snowflake addresses that. In fact, the brand companies that I've got using this and the printers that I've got using it with their brands, they keep the snowflake of, let's say, the Ritz Red that the brand manager signed off on, so that this is evidence moving forward that these are your tolerances for this color, so that we can put to bed who's judging what and who's expecting what. It's one set of numbers for all tolerancing. And we've been playing with this snowflake and the numbers, trying to get the numbers to have a uniform appearance. And we figured out that this could easily lead to developing a new delta E formula. And for you ChromaChecker users that I'm going to ask you to hold on after the session, I'm going to share with you the numbers that you can enter into your snowflake and be your own judge in terms of how uniform it makes the colors. And if we get some consensus with a number of users, we can use this as a beta set to actually come up with a new delta E formula, so we can get back to maybe one number to define tolerance versus having to go through a fairly complicated process of the snowflake to set the tolerances. So stay on after the session to learn more about this snowflake offset that can help us develop a new delta E equation. And this whole process is really easy to do. If you own ChromaChecker, you can use Capture or the cloud to choose a color, make a variator, print a variator. Ideally, if you have a quality printer, you can print it and you can see what the results are. I'm going to show you an actual print that I made on my Epson. And I did this color, and it's a 2 delta E. Well, the variator, the way it works is you can have any range. So you say what delta E's you want. Mine went from 1.5 in half a delta E increment to 6. So here I've got 2.5, 3, 3.5, 4, and so on. And what I did was, when you take a look at this, each one of these is a 2 delta E. I manually went in and measured them to see, is it really a 2 delta E? Because depending upon how good your profile is for your printer and your color management, this prediction works really well. And you can even make it better with spot color lookup tables, which ChromaChecker handles really easily. And so for this, I'm just going to exit out of here for a second and go into my Capture software. So this is our client software to measure color. And I'm going to show you that I measured this, this color. I measured the center of the circle for magenta and made that my reference. And then I used Variator to measure the 9 squares or the segments around the 2 delta E. And let me click on that now. And when I click on it, look at this. Here's the lightness, and that's measurement number 1. Measurement number 2 is into the yellow, measurement 3 into the orange, measurement 4 into the magenta, 5, 6, 7, 8, 9. So you see in LAB color space how these colors are plotted, actually plotted in the color space. And if I click on the magenta here, which is my reference, and I go to my QC measurements of my variation, you can see that I can compare the center to any one of the segments. So comparing it to number 6, it's a 1.9. Comparing it to number 7 is a 2.0. That's exactly what we're looking for. We're 2.0, 1.9 delta E. That's exactly what we want. So what we're seeing on the screen, or what we're seeing on the physical print, I mean, yeah, it's great to look at it on the screen, but if you can have it in the print, how powerful is this that you can take brand colors, print them out like this for the brand, and say, hey, tell me what you can live with. Tell me what you can't. And then based on what the answer for what they can and can't live with, then we can go in and we can click on the snowflake, and we click on the snowflake in the color space that we set up our variator on. So here I'm setting it for my Epson, and I always go 16-bit if I can. And then when I say download, notice we now have include control strip, and I can do a target comparison, which puts the center patch on the side. And when I say download, ChromaChecker is now downloaded that file into my capture directory. So if I go to my desktop and go to my capture export, and I open up my snowflake, so here's what I just downloaded. You can see this is what just downloaded. I've got my control strip. You can see the target. So this color here is represented in the bottom third of the patch. And then we have our snowflake tolerancing on the left. And this is where now the customer can go in and say, hey, you know, I'm okay with this. It's a 3.4 delta E. I'm not okay with this at a 3.8 delta E, but I'm okay with that as at 2.9. So this allows you to then have them circle this and then set the tolerances here in the snowflake and then enter those tolerances within ChromaChecker. Now, at the conference, if you were there, Tim showed us a unique capability of using our, Tim Quinn did a unique capability of using our spot color placeholders. And so I've got a color bar here where I made Snowflake, which is now in the public library. So a color bar called Snowflake is in the public library. And what it allows me to do is call it up, and it represents the control strip on the snowflake. So here's the control strip. And now I just replace it with whatever color I want it to be. So this is my gray 1538. So here's my gray 1538. So now I'm going to put it on my table here. And using capture, I'm going to use my I1 to measure this color. And it's just one quick strip. So here it comes. If I didn't pick it up too early. Yep, here it is. So it's done. Now I can go into the cloud. So I'm going to go to the ChromaChecker cloud. And I'm going to go to my track that I put this for, and I put this into an indigo track. Here it is, 11. It was done 5 seconds ago. So when I go to 11, I've been logged out too long. So just let me get back to that point. So here it is. Here's the measurement I did 5 seconds ago. And when I click on it and I go to my patch list, look at the distribution of the snowflake in LAB color space. Okay, this maybe a little color geekish here, but it shows you how we're mapping the colors so that we can ensure a tolerance that is within your color expectations for a color match, despite delta E flaws. So with that, that's pretty much the content that I had for the majority of our users. Does anyone have any questions at this point in terms of building these custom tolerances and accommodating for weaknesses in the LAB color space? No questions?
Don't have any right now.
Oh, and by the way, now that I've got this in ChromaChecker, each of the squares in the snowflake have a number in brackets, 1, 2, 3, 4. So if I look at 4, 4 says that it's going to be a 5.36 delta E. And when I look here, it does. It says it's a 5 delta E. So in this way, these numbers, and by the way, I've actually tested it. Here's one of the snowflakes where I physically actually measured what the actual delta E's were, much like I did with the variator. I measured what the delta E's were, and then looking here on the list here, I can look at square number, that one's number 8. The bottom of it is 8 because they go 1 through 8. So I can look at square number 8, see what the delta E is, and it should be the delta E that's predicted here and what's actually measured. So we have some fun ideas on what we could do to make some snowflake specific graphs and charts that document the delta E's so that when you are helping someone understand, like one of the limitations of delta E is that color doesn't always look the same. Here's a case in point. So here's snowflake. And in this snowflake, I set the LAB offsets. So all the colors will look pretty uniform. And so I would say the visual difference here is the same as the visual difference here is here is here is here. But when you look at the numbers, 6.2, 7.9, 4.2, wait a minute, these numbers aren't anywhere near the same. We're an 8 and a 4 and a 4. And yet visually, I'd say the relative difference here is the same as the difference here. That again just shows you that delta E doesn't always represent consistent color differences. And using Snowflake, it really shows us this.
Dave, I do have a question.
Yeah.
Now, how does the RIP recognize the different LAB for a spot at the RIP?
Okay, so great question. So it really depends upon your RIP. You can do it a couple ways. My RIP is Print Factory, driving my Epson. And what I do is I set my RIP with color management turned off, and I save my files in device CMYK. So the Epson CMYK profile that Print Factory made for me, I take out of Print Factory, I put into ChromaChecker. And then when I build the snowflake, so let's do this, I'm going to go into my capture, and let's say I'm going to build a snowflake for this gold color. I'm going to click on Build Snowflake. And so I'm going to say the PDF color space is CMYK, and it's in the device CMYK color space of my Epson, which I built here, my Epson Glossy. And if I built a LUT, I could assign the LUT here, so you could have the lookup table be applied to the snowflake. And then I set my color bit and whether or not I want to target comparison or not. And then I say download, and now it's downloading the new snowflake, and then I bring it into the RIP and I print it to the printer without color management. So I turn off my Grackle simulation in my RIP, I send it to my printer, and I've got it. It's that easy. Now, different RIPs make it easier or harder to turn off color management. So, and whether or not you profile the device as RGB or CMYK can play into it. Some RIPs can honor an LAB through the RIP interface, so you don't have to worry about working in a CMYK or RGB space. So it's kind of, I hate to be vague, but it is dependent on your RIP. I can tell you exactly how I'm doing it on Print Factory. All right. So with that, I'll say bye to everyone who, well, let me just say, if you're not a ChromaChecker user, you can download ChromaChecker by going into the registration button, and we'll set you up with a free version of Capture that you'll be able to use and build variators and build snowflakes. It gives you full functionality for all this. And literally, it's this easy. So for you users that might not know ChromaChecker very well, and we've got videos on how to do this, what I'm going to do is I'm in my Quick Checker tool, which works with handheld measurement devices like a Nix or a i1 or what have you. And I'm just going to grab a color here. I'm looking for something that's interesting. Well, here's an interesting color, this fluorescent orange. And I'm going to measure that color. And as I measure that color, it comes up and says, okay, it's this color. And now from this point, I can go ahead and I can make a grid, a variator, or a snowflake. So if I go to variator and I say, hey, I want 0.5 delta E steps plus minus 3 in LAB color space, or if I'm doing monitor, I could do RGB and I could do do it into like my monitor color space, but we'll just keep it LAB. And I'll say download. And now it's downloading that file as a PDF. So now I'm going back to my Finder. Here's my variator. And as I open it up, you can see there is the first page at 1.5 delta E. Here's the second page at 2, third page at 2.5, 3, 4, 3.5, 4, 4.5, etc. So now you can start to really see the differences at 4.5. And in this way, educate your customers on what a delta E is. I mean, how easy is that? That's unbelievable. It's so simple. So if you don't have ChromaChecker, I hope you this has motivated you to download the software and make some variators for yourself and educate yourself on Delta E. So with that, I hope you guys enjoyed today's session. Tried to fit a lot into the hour. I hope you enjoyed it, and thank you for attending, and please follow us on LinkedIn, and hope we see you at next year's color conference. Mark it on your calendars now. It's this week next year in beautiful Newport Richey, Florida. So hope to see you then. Thank you.